Final, you are going to get a couple of questions from the first part of the course, and those questions are going to be only from this concept that we are going to cover today. Okay, so this is it, 2.4. And we are going to end up with a chain rule formula. That's the name, chain rule formula. It's going to be derivative of a composition function. When you compose a couple of functions together, how are we going to differentiate it? I have to refresh your memory regarding the composition of functions from your previous course to make sure we have no difficulty, and the way we are going to, of course, apply it in this section, not the way that you did it in your algebra course, if you like. Okay, so you let me know if you have any question on this definition that I'm going to do, because they're going to be useful for us. So the review is going to be, how about composition functions or composition of functions? You see, like in everyday life, sometimes you have to do something, but you cannot do it the right way. So you have to go through different channels, different steps. That's the idea. So what is going to be the composition function? You see, in this case, we are going to be given a function. So our first function would operate like you have the x. Remember, this is your input. So you're going to put it into the first function, whatever it is. Okay. This is going to be your function. It's like you apply for a job. If you apply for a job, first thing to do, you have to submit an application. So in this case, you are going to get f of x. That's the first step. You apply for the job, they receive your application. They check your application. If they like it, they ask you to come for an interview. So your interview is going to be your second function. You see the second function? Interview function, or the G function. The G function would operate on f of x, would operate on your files. So the result is going to be G of f of x. That's it. You may continue, of course. You may have a second interview. So you are going to bring another function. So you may go through several steps. But if we take care of the 2 steps, then we can repeat it over and over. So this G of f of x is going to be denoted by G of f x, and is going to be called the composition function of f and g. Okay, so that's the one that we are going to be interested in. So we give you the official definition. Okay, so what's going to be the official definition? If 2 functions are given, okay, if the functions f and g are given, then we can define the composition function. Then the composition function, composition function that we are going to denote by G of f. Okay, G of f is going to be defined by, that's it, G of f at x is going to be G of f of x. Remember, this is not a multiplication. We call it, it's a composition. Okay, the order is important. So you apply, first, this is it. And then when you're done with the first one, then you bring the G on it. So in this section, we are going to call this f function, we refer to it as an inside function. That would help us. Okay, we call this one inside function. Okay. And this function over here, G, we are going to refer to it as an outside function. Outside. function. Okay, so that would be the composition of two functions. Any question? Similarly, of course, you can, if you switch f and the g, so you have to switch your functions. So let's get one example, the way we like it in calculus. In algebra, those two functions were given to you. Do you combine them together? So what we would like to do is, we like to do it the other way around, if you like. The result would be given to you. We want to think about it as a composition of two functions. So you have to identify that g and f for us. Okay, so this is the way we are going to use it in calculus or in this section. Example. This is going to be our example. So the example is going to be, would like you to find two functions. Okay, would like you to find the two functions. Okay, there you are. Find two functions. We are going to call it f and g. F and g such that, okay, such that h of x is the name of the function, is going to be g of f of x. Okay, for all x. For all x. So for each of the following cases, I'm going to give you all the cases that we have in this course. For the following cases, for the following given, if you like, given function h of x. So the h of x would be given. So what would like you to do for us? Would you like you to find, okay? So we would like you to find this, okay? We would like you to find h of x for us. Okay, are you ready? The first one. You see, the first one is h of x. These are exactly the example that we're going to use. Equal to the x cubed plus 2x to the 10. You see, that's going to be the one. So we'd like you to find two functions so that if you combine them together or compose them together, that give you your h of x. You see, it's like the order of the operation. Remember the order of the operation, we do inside parentheses first. Inside parentheses first, then we do the powers. So if you want to think about it, that first action that we do, which is going to be the inside one, this is going to be your inside function. So this is going to be your f of x. So the inside function is going to be x cubed plus 2x. Outside function, when you do it, then you do the powering. So the outside is the power function. The inside is just whatever is inside that parentheses. Okay, so if you like, the solution is going to be, so what we can do is, you are going to, suppose I'll go to the next page to give you more space to explain it. So this is what would happen. So what we're going to do, I'll just repeat that function again so that we have it. You see, this is our h of x. So the h of x was x cubed plus 2x, everything to the 10th. So we are going to take this inside function, okay? This is it. So we're going to take this inside function to be over f of x. Okay, so f of x is equal to the x cubed plus 2x. That's the inside function. So the outside is just powering. So g of x would be x to the 10. Okay, so the peak inside function is just x cubed plus 2x. Okay, so this is going to be the inside. Okay, that's going to be the inside. And this is going to be the outside function. Okay, outside function. Now we're going to confirm it. And the confirmation is if you compose them together. So g of f of x is going to be equal to what? is going to be g of, we bring the f first, x cubed plus 2x, and then we apply the g. What is the g? G is just the powering function. You see the action of the g is, x is like a box. You see, look at this one. So g of the box is going to be a box to the 10. You see, that's the function. Depends what are going to drop into the box. If you drop x into the box, g of x would be x to the 10. But if you drop z into the box, that gives you z to the 10. So what are you dropping into the box? You are going to dropping this one into the box. You see, you drop this one into the G box. So the result is going to be what? The result is going to be box to the 10. So what is inside the box? Inside the box is x cubed plus 2x to the 10. You see, this is the way you think about it when you compose them together. So that's it. So we just bring two. So you can say that h of x, yes, is going to be composition of outside function times the inside function. This is the way we are going to think about this type of function. Any question? Now, what is going to be the application, or what is the chain rule in this part? You see, informally, we just do it informally, then we give you the theory. Informally, this means this function will be given to you. Of course, it's parentheses raised to the 10. You want to differentiate it. We want to find the h prime. If it's a square, it's easy. You can square it. Okay, you can square it and find the derivative of the resulted function. You may say that, oh, I can do the 10. I can use binomial expansion. Okay, I change it to the 10,000. Then you can't do it. Okay, it can be done, but you cannot write it down. So what you are going to do, we are going to get the help from the chain rule. The chain rule is going to be, you see, if you want to find the derivative of a composition function, this is the step that we're going to do. It's going to be derivative of the outside function times it by the derivative of the inside function. You see, we are going to show you in a minute, but just give you a motivation. The motivation is going to be, it can be proved, or we are going to do it. It can be proved that if you want to find the h prime of x, it's going to be simply derivative of the outside function. You see, outside function prime times it by derivative of the inside function. Inside function prime. What does it mean? This means h prime of x is going to be equal to, you see, outside function. What is your outside function? Your outside function is just a power function, box to the 10. Remember the power rule. What's the power rule? Box to the 10 would be 10 times box to the 9. X to the 10 would be 10x to the 9. Z to the 10 would be 10z to the 9. What do you have now? Box to the, this is your g function. The outside function, you see, outside function is going to be, this is going to be the outside function. You bring the 10 down, 10 times the box to the 1 down. Okay, 1 down would be 9. What is in your box is going to be untouched. You see? You may think about this as z to the 10, 10z to the 9. T to the 10, 10t to the 9. Box to the 10, 10 box to the 9. So that's the derivative of the outside. Times it by derivative of the inside. What is the inside function? Inside function is whatever you have inside the parentheses. So what is the derivative of x cubed plus 2x? Derivative of the inside function. Any suggestion? What's the derivative of x cubed plus 2x? Who wants to try? Derivative of x cubed.
3x squared plus 2.
Very good. 3x squared plus 2. That's it. That's the chain rule. And we are going to show it in a minute for you. Okay, so if you want to find the derivative of this complicated function, if it's a composition, as soon as you see it, as soon as you see a parenthesis raised to something, it's a chain rule. Because it's two operation inside the parenthesis and operation outside the parenthesis. So what's going to be the chain rule? Derivative of the outside, whatever action it is, times the derivative of the inside. Derivative of the outside always would be power. You bring it down, 10, 9. It's done all the time, 10, 9. But the crucial part is the derivative of the inside. You times that by derivative of the inside, which is 3x squared plus 2. You're done. You can't do anything about it. Any question? That's a type 1 of the examples that we're going to have. We have 2 types only. Give another one. Then I introduce officially what is the chain rule is. So what's going to be the second method that we are going to be interested in? You see, the second method is going to be kind of a trig function, sine, cosine, tangent, secant, and in future, e to the x exponential function and the ln function. So let's start with this one. Suppose h of x is sine of x squared. Look at this one. You see, this is a composition of 2 functions. If you have only sine x, it's a 1 function. Sine x is 1 function. But it's not sine x, it's a sine of x squared. So you have 2 functions. The inside one, you see this is going to be your inside function. So this is going to be inside. So the inside function is just x squared. Outside function is the sine function. You see outside function, outside is sine. Okay, you can call it sine of x, sine of t, whatever. So it's a sine function. Okay, so again, we have a composition of 2 functions. So let's do it, introduce the functions. And so they ask for the f and the g. Again, we say that this is going to be the solution of this one. So we are going to suppose the inside function, we call it f of x is equal to the x squared. Okay, and the outside function is just a sine function. G of x equal to the sine x. Okay, now what's going to be the composition that you are interested in? You are interested in f g of outside, g of f of x. So it's going to be g of f of x is x squared, g of x squared. Okay, so what is the g? You see g of the box is sine of the box. You see, g of the box is sine of the box. So it depends what I'm going to put inside the box. Inside the box this time is x squared. So that gave you sine of, okay, sine of x squared, which is your h of x. Okay, so your h of x is going to be equal to the g of f of x, and you're done. Any question? Now let's try to see if you can find the derivative of this function. So what's going to be your derivative of the function? You see the derivative, h prime of x is going to be what? I just repeated. Derivative of the outside, you see outside, times it by derivative of the inside function. Inside function. So in this case, it's easier. So h prime of x is going to be equal to derivative of the outside. What is your outside function? Outside function is a sine function. Derivative of the sine function is cosine function. But cosine of what? Cosine of x squared. So that would be derivative of the outside times derivative of the inside. What is your inside function? Inside function is x squared. Derivative of x squared is 2x. See? But we usually put the monomial up in front. So h prime of x is simply 2x cosine of x squared. And then you're done. Done. You see, this is all sorts of examples that are going to have for the chain rule, but we have to make it official and put them together, and that would be application, or how we're going to apply the chain rule in order to get the derivative of two functions. So your cases are going to be, you see in this course, this is sine, it may be cosine, it may be tangent, it may be secant. In future is e to the x squared exponential function, and then we get ln of x squared. These are all the possibilities that are going to have. So if you see anything other than the x here, it's a chain rule. Okay, it's a chain rule type. And if you see parentheses raised to something, it's a chain rule. You are not going to have any other type of examples that we're going to refer to as a chain rule. Okay, so basically the chain rule formula, it gives you, okay, the method in order to find the derivative of a composition of functions. And basically the derivative of composition function would be derivative of each function, you multiply the product of the derivative of the outside times the, remember, it's not the product rule. It's a product of those two functions that we are going to have. Okay, let me make it official. Any question? So make sure you understand the term of the composition of functions. So the composition of function, you know, you want to do something, you have to compose them together to get these numbers. Can you think about any everyday life function, example of a composition function?
Professor, I actually have a quick question.
Yes.
So on this one, would it be marked wrong if we forgot to move the 2x in front of the cos x squared?
Yeah.
Okay,
It's customary. Get used to it, because that would be useful for us for the rest of the course. It's not wrong mathematically, okay? But you know that always monomials, a single term goes up in front, because we are going to have several formulas in future, and that would depend on the order that you write it down. So keep in mind.
Got it, will do.
And the other one is sometimes you may get this 2x here, you will see it in a minute. You may get a 2x, then you multiply by 3 here. You see, if it was a 2x and times 3, you cannot leave it. You have to simplify it. And so that's why we just put it, always put it up in front in this course, always, okay? It's
Got
not
it,
the,
will do.
it's not the wrong, but it's not customary to write it down. Any more question? So we're going to make it official. There are 4 cases of this chain rule. We talk about it. There are 4 cases. We'll repeat it on your next quiz, quiz 2, next test, test 2, and on the final. From whatever we did so far, we usually give you one question, one concept that we're going to be interested for the final, and that's a chain rule, because this is the one that, you know, we need. Just for fun, for everyday life. So when you go shopping, you see, especially if you go to Macy's. So as soon as you arrive in the shop, they say, oh, there is a special day. We have a 50% off, okay? And then they give you a notice that an extra 10% would be given to by the cashier. So I want to know why they don't just tell you that it's 60% off, okay? So you go to the shop, you see the notice that everything is 50% off. But they say, since it's a special day, we are going to give you another 10%, you know, when you go to the cashier. So why they don't give you, psychologically, you may think that they are going to give you 60% off, which is not, because that's the way they are going to use composition. Look at this one. You know, it's not bad for one to see it. You see, when you go to the cashier, this is the item that, you know, you would like to buy. When you go to the cashier will bring the 50% function first. You see the 50% function. So that would be 50% off. And this is the amount that you're going to pay, which is a f of x again. Okay, then they are going to take 10% of this one, not the original one. So then they bring, okay, they bring the the 10% machine, and that give you, you know, the composition of two function, and you pay for it. You see, if you put them together, so the first one must happen. You see, you must have the inside function first. So that's why they apply the 50% to the inside function, the purchase. But from the new one, they take out the 10%. So you may think that they give you 60% off. It's not. If you calculate it, it may be something like 55%, not the 60%, because they use composition function to get these numbers, okay? So that give you a fun part that you will see it in everyday life, various application of this composition function. Okay, any questions? So I'm going to make it official. What is the chain rule? Okay, that is going to be our theorem. It's just basically what I talk about it. You are going to be given a composition of two functions, you want to differentiate it. So the derivative would be derivative of the outside function times the inside, okay? So I have to word it carefully. This is it. If the function, okay, if the function, let's say f, they must be differentiable, of course, is going to be differentiable okay, if this is going to be differentiable, let's say at x, that is our inside function. So we make sure that we have f prime of x and the outside function, and g is going to be differentiable. Of course, we apply the g to f of x, so this must be differentiable at f of x, the result that we're going to get. Okay, if this is going to be the case, then the composition function. Then the function, we compose them together. The function would be h of x, which is going to be the outside g inside f. This is now going to be differentiable. Okay, this is also differentiable, is also differentiable. Of course, it's going to be differentiable at x. And the result is going to be the chain rule formula. What is going to be the chain rule formula? That derivative of the h prime of x is derivative of the outside, g prime of f of x, times it by the derivative of the inside. Okay, derivative of the outside times the derivative of the inside. Okay, so that's a general version of our chain rule. Okay, any question? Now we're going to simplify it, this formula, and we give you a different format that would be easier to apply. This is the way we're going to apply it for the rest of the course. Okay, so the simplification of this formula is going to be, suppose we call the inside function short, you call it u. So suppose the inside function is customary formula for the chain is going to be f of x. Of course, in that case, u prime would be, okay, f prime of x. If you use this notation, then you have a nice version of the chain rule. Okay, the version is going to be now, remember this is g or f. So this means if you want to find the derivative of a composition function of a gu, g is the outside, you see that's a g of f of x, g of u. If you want to find the derivative of a g of u is going to be equal to derivative of the outside, g prime. G prime of what? G prime of f of x, we call it g prime of u, times the derivative of the inside. It was f prime of x, so it's going to be u prime. This version is easier to apply, and we are going to apply it for the trigonometric function, exponential function, and the ln function in future. Okay, so it's basically the same thing. So the g function is the outside. G function is the outside function, u is the inside. So it's going to be the derivative of the outside times the derivative of the inside. Okay, so in future, for example, if you have sine u, sine of x squared radical x, x to the fifth. If you want to find the derivative of a sine u, it's going to be the derivative of the sine, which is cosine of u times the u prime. If you want to find the derivative of the tangent of u, so the derivative of a tangent would be secant squared times u prime. If you want to find the derivative of a secant of u, the derivative of a secant would be secant u tangent u times u prime. You see, that will help us quite a lot if you think about it in this format. So this is one format that we're going to use. Another format is if this is going to be outside one, it's going to be power function all the time. So a special case in particular, that's the other case. We have no other form. Okay, in particular, if the outside function is always the power function, is going to be u to the n. Okay, that's going to be u to the n. Then you see, then this outside function, derivative of u to the n, just using power rule, then g prime of u is going to be simply u to the n minus 1. Okay, and if you apply it to this formula, so the result would be what? The result would be this. G of u is derivative of u to the n. Derivative of u to the n is equal to derivative of the inside. You see g prime of the power. You bring the power down. N u to the n minus 1 times u prime. You see, that is the famous version, especially case of the chain rule that we're going to use through this course. It's just like the power rule. Remember the derivative of x to the n x to the n minus 1. But this is not x to the n. It's a parenthesis, a function, okay, like the one that we did. So it's not going to be x. Again, it's going to be action of differentiation. We say it's a chain rule outside the power function. The power function n u to the 1 dot times the inside u prime. So true version only. This version is going to be used for composition of u with a trigonometric function, exponential function, ln function. This version used for all the power function, parenthesis to something. And then we're done, okay? There are some other notation for the chain rule in your book, or when you see it from time to time, but this is the easier format or the easiest one to be able to deal with it. Those notation, we call it differential notations. We can talk about it later when we get to the differential, but not now. We don't want to make it complicated. Okay, so this is going to be the chain rule. Just make it official here. That's a chain rule formula. Okay, that's one. And this would be referred to as it's like the power rule, but they call it the general. The general. Okay, the general power rule. We refer to that's a general power rule, of course, when we differentiate of differentiation. Of differentiation. That's it. That's it. Two formulas that we're going to have for the chain rule. We're going to get example to see there are 4 cases. 4 cases, 2 applications, make it into the 6, and we give you all of them in your next quiz, next test, and on the final, we just give you those derivatives. Okay, any question? So let's apply it to see how we're going to operate these formulas. So make sure you remember this one, especially this is going to be used for the, again, second part of the course. And so it's a composition, it's not x. If it's going to be x to the n, it's just one function. Derivative would be n x to the n minus 1. That's it. But it's going to be a parenthesis raised to the power. That would be chain rule. So you do the power first, you bring the power, no other action, but the action would be derivative of the inside. And this would be when we compose the function u with some famous trigonometric or exponential function for future. Okay, are you ready? Any question? So let's operate to see how we're going to do it. 4 cases. I explain all the 4 cases, but I will change it into the 2 cases only for future. Okay, 4 cases for the first part. And then for this one, we have to bring the trigonometric function. We do it later. So let's see what's going to be those 4 cases. 4 standard examples. And then you're done with the application of the chain rule for the first part. Okay, there you are. So example. We want to find the derivative of each function. In your book, they say, apply the chain rule to find it, but you don't need to be too old because you have no other choice. Okay, there you are. Find. Pay attention to these 4 cases. Find the derivative. Okay, find the derivative of each function. What is going to those 4 cases? Case 1. It's just a power function. It's parentheses raised to some. You see f of x equal to 2x cubed plus 5x raised to the 20. You see, as soon as you see this one, we say it's a chain rule type because it's a parentheses raised to 20. This is how you can think about it. You can do it in a short form, but I just explained this first one. You see, you think about it that you say, okay, so what I can do is I can call this one u. So what I have is f of x, if you like, is equal to the u to the 20. So remind yourself the formula. Derivative of the, so f prime of x would be u to the 20. You see the formula? That's a power rule formula. U to the n is u to the 20. So it's like a u to the 20 prime. Action of differentiation. Bring the power down, 2. U to the 1 down, 19. That's the outside function. Times the derivative of the inside, u prime. That's your formula. Okay, so it's like u to the 20. So it's going to be 20 u to the 19 times u prime. Now copy this formula. So if you copy the formula, f prime of x would be power down 20, you see, 20, 19. That's the first step. Then derivative of the inside. This is the way you do it. You see, so that would be 2x cubed plus 5x. Derivative of the inside. So what's going to be the derivative of 2x cubed plus 5x? It's going to be 6x plus 5. And you're done. You say you don't need that.
Is it 6x squared plus 5?
Sorry? Oh, yes, thank you. 6x squared plus 5, and then we're done. Okay, easy to do. You see, power first, 2019, u prime. So in the first part, the action is just the power rule. 2019 is action of differentiation. On the second part, prime. We call it u prime. Okay, so always we keep saying that, don't forget u prime. So you have to pay for it, that's it. 219 is usual one, but the derivative of inside is going to be u prime and you're done. If this is going to be a monomial, you have to put it up in front and simplify it. Okay, monomial. Otherwise, don't take any other action. Some people, I've seen some people, they move the 20 inside. No, you don't need it. You're done. Okay, that's a case 1. Any question? If you want to make it exciting, give you another one of this type. You bring, a trig function. G of x equal to the x to the 5th. Okay, plus 2 secant of x raised to the 8th. It's a parenthesis raised to the something, so it's a chain rule. So what's going to be your formula? Again, you can repeat it for yourself. Say, oh, I'm going to call this one U. So what I have to do is solution. So I have to differentiate U to the 8. Repeat your formula if you like. You see, your formula would be 8 done, 8 U to the 7 U prime. You don't have to write this, okay, on the test pad. That shows you what action are going to take. So what's the result? G prime of X is equal, copy the formula. Bring the 8 down, 8 X to the 5th plus 2 secant of X, raise it to what? 7. But times it by U prime. Derivative of the inside. Derivative of the inside, derivative of X to the 5th would be 5X to the 4th. It's going to be plus, it's a 2 times secant, 2 times derivative of secant. It's going to be 2 times secant of X, tangent of X. That's it. That's a little bit more involved. They want to give you something different on the test. On the quiz, they put, this is secant, secant, sine, cosine, tangent. They bring one of them, to make it more exciting. And there is no monomial around. Okay, this is up in front, so we are done. Any question? So the case 1 is just U to the N, if you like. Parenthesis raised to the something. Action is going to be outside 8, 7, 8, 7 U prime. That's it. The first action is power rule. The second action is a derivative of the inside. 8, 7 U prime. And with that. That's our case 1. Any question? And for case 2? That's case 2. Number 3. Case 3 is going to be a radical function. You see f of X equal to something like the cube root of X squared plus 3 tangent of X. That's it. A radical function. Any suggestion? What I'm going to do first for this problem when we see the radical? Any suggestion?
Rewrite it.
Yeah.
Excellent. Yes, we don't like radicals in calculus. Okay, rewrite it. When you rewrite it, we get to the first case. But the difference is your power is going to be rational numbers. Okay, excellent. That's it. Solution, rewrite it. Rewrite the radical all the time. F of X is going to be equal to is X squared plus 3 tan X. Okay, everything to a third. You see, it's again what? It's type 1. It's type 1, and you remind yourself that, oh, I have to find the U to the 1/3. You want to differentiate U to the 1/3, bring the power down, 1/3, U to the 1/3 minus 1. 1 minus 3 would be -2. -2/3 times U prime. This is your formula. Okay, is the U type, we call it. And action of differentiation, we bring the power down, 1/3 U to the -2/3 times U. Now copy this formula. So what's going to be the result? F prime, power first, 1/3, no change inside, remember. X squared plus 3 tangent of X to the 1/3 minus 1, which is going to be -2/3 times U prime. U prime derivative of the inside. Carefully differentiate, the derivative of X squared will be 2X plus 3 times tangent, 3 times derivative of a tangent. And you know that the derivative of a tangent would be secant squared. Secant squared. And then you're done. Okay, again, no simplification is possible. And simply you are done. Okay, any question? So that would be your case 2, because it's the radical one. I give another one from this. It's not really a case 2, we call it, it's a case 1 again, because you're just changing the power. Sometimes you need a little bit of simplification. This is the one that we are going to use mostly for the tangent line problem. So how about g of x is going to be equal to, okay, let's have the square root of, okay, that's it, the square root of 4x squared plus 5. Okay, we want to do this one. Again, it's a radical function. We have to switch it. Okay, so we switch it first. Solution, or rewrite it. Solution is going to be, this is going to be g of x equal to, now if you switch, that gives us a 4x squared plus 5, everything to the half because of the square root. So it's a u to the 1/2. So remind ourselves that I need this formula this time. U to the 1/2. Okay, bring the 1/2 down. 1/2 u to the 1/2 minus 1, negative 1/2 times it by u prime. This is going to be your formula. Okay, so copy the formula here to get the solution. So g prime of x is going to be equal to 1/2 done is going to be 1/2. Okay, no change here, 4x squared plus 5 to the negative 1/2 minus 1, which is a negative 1/2, times it by du prime, derivative of the inside. Now its derivative of inside is going to be 8x, and derivative of 5 is 0. Okay, any question? But you're not done. You're not done because there's a monomial all over the place, as you see. You have the 1/2 as a monomial here and an 8x here. So what you have to do, you have to bring these together. You're not done, you have to simplify it for us. So the final answer would be this one. You can do it right away or just explain it. So it's going to be g prime of x equal to the 1/2 times 8x times 4x squared, okay, plus 5, everything to the negative half. Okay, now that gives you the chance to simplify the 2 and the 4. You can do it here, we accept it. Okay, so that gives us a 4. So the final answer is g prime of x is equal to the 4x times 4x squared plus 5, everything to the negative half. Okay, so that's your extra job. The only simplification that you're going to do when you're dealing with the chain rule, just take care of those monomials. If there are going to be no more monomials, if there's not going to be one, just simplify it. You must simplify it. Okay, this is part of your job. Any question? So that make it into one type, really. What we call it the type 1 and the type 2. So the first one is just parentheses raised to the power. And the second one is a radical function. And we know that in calculus, this is the way we do it. We always rewrite the radicals. So the next two cases are going to be the tricky one that we're going to have. Now what's going to be the next one? Are you ready? So this is going to be, this is the case that you get a product of two functions. Okay, you want to differentiate product of two functions, and you may have to go through the chain rule. Okay, so pay attention to this one. It would be fine, but we're just checking this. So this is going to be our number 5, or I call it case 2 or case 3. Okay, so let's see what's the function. The function is this one. You want to differentiate. Let's start with this. F of x, very popular. Okay, it's going to be given in various places. 5x to the 4th, and that give you x squared plus 3x, everything to the 7. And that's the one you got to be careful. You see, this case is a product of two functions. You see, the first function is this one. We call it the first function. Okay, and this is going to be your second function. So you have to apply the product rule. So remind yourself that I need the product rule, and this is the product rule. Derivative of the first, f prime, times the second one, plus derivative of the second times first, which is going to be s prime f. Okay. Now, derivative of first is easy because that would be 20x cubed. But derivative of the second times first, you got to be involved with the chain rule because the second one is a type of u to the 7. Okay, so this is the one that you got to be careful, and this is where you face the chain rule for these type of problems. So you may remind yourself that, oh, we do it. So you remind yourself that I do need derivative of u to the 7 for the second one, and this would be 7u to the 6 u prime. Okay, so we are prepared to be able to do it. That's it. So we just using these two formulas to get the solution. So we have to apply the product rule first. That's it. F prime of x is going to be equal to derivative of the first one, 5x to the 4th, derivative would be 20. Okay, 20x cubed, that's the derivative of the first one. Times it by the second one, x squared plus 3x to the 7. That's the first part. Okay, so that's going to be derivative of the first times second. Any question? Now plus, this is the one you got to be careful. Second first, second. Second is a chain rule type. So u to the 7, you copy the formula, you bring the 7 down, 7 x squared plus 3x to the 6 times u prime. Remember, u prime would be 2x plus 3. That's the derivative of a second one. Okay, it's always the case. The second one's going to be chain rule type, but times it by the first. Some people, they miss this one. Times it by the first one is 5x to the 4. Okay, so we apply the product rule. Of the first function, 20x cubed times the second function plus the second times first, second, 7, 6 u prime, chain rule. 7, 6 u prime, 2x plus 3 times it by the first function. Then you check to see if the monomials are round. Yes, you see the monomials. You have the 5x here, the monomial, and the 7. So you have to simplify this. Okay, you bring this one up in front, or you can do it quickly. 7 times 5, 35, x to the 4th, and then okay, then you're done. So the simplification and the final answer would be f prime of x equal to 20x cubed times x squared plus 3x to the 7. Okay, plus 7 times 5, 35, 35 x to the 4th. Okay, times it by the leftover that we have here, x squared plus 3x to the 6 times 2x plus 3, and then we're done. Okay, that's the final answer. Again, don't move on. Some people, they do all the multiplication, they give me 1-page solution. No, you won't get any point for it. So the simplification in algebra, this is it. We just change this monomial, and there is no like terms, anything to make it, easier. And then we simply done to this type. Okay, so it's a combination of a chain rule and the product rule all the time. So the way we are going to give it is going to be exactly as you see it. We just apply the chain rule to one of them. In your book, they give you more of them as the parentheses rate or something. They make it complicated, but we don't need it. Just get the idea for this form, and then you'll be fine to get this through. Okay, any question? So that's case 3. The product and the chain rule. We have one more case. How about the quotient? Okay, that's one that we are going to disagree, if you like, on the test, the way you are going to apply it or I apply it. You see, the function is going to be a rational function. So this is your function, f of x equal to, okay, f of x equal to the 8x plus 1 divided by, this is a kind of a challenging one, x squared plus 2 cosine x, everything to the what? Everything to the 10. You see, this is the case. Now, you have two options. The first one is quotient rule. Some people, they like it. So if you want to use the quotient rule, you know that. If you use the quotient rule, you have to simplify your final answers. It takes quite a while to do it, but it's okay if you want to do it. So the quotient rules would be derivative of the top times bottom, which is easy. Derivative of top would be 8 simply, times bottom, minus derivative of the bottom times top. But bottom is due to the 10. Then you have to apply the chain rule, 10u to the 9u prime. The difficulty with this method is you have to simplify your final answer. But my suggestion is ignore the rational form. Move it up. So see, this is the one, x squared plus 2 cosine to the 10. You move up this one, we change this one to the negative 10. Then we have the product, and then we can do it. The advantage of this method would be the results already simplified. You don't have to do anything about it. Besides, if you get used to this type of function, that will be good for you when we get to the last part of the course. In the last part of the course, we are going to have something we call it integrations. We do the opposite. So for that opposite, you have to do this one all the time. And you know, if you want to go take calculus 1, 2, 3, that's a good method to do it. So that's my suggestion. I've seen some people, they don't like this one, then they spend so much time to do quotient rule. I don't mind. But suggestion is move it up. If you move it up, it's going to be product. And you already get the case of the product rule and you'll be able to do it right away, okay? But unless, you like to do the quotient, we don't mind. So this is my suggestion. Change it. So it's going to be F1. You say in this course, my suggestion is the only time that you use the quotient rule to differentiate is this. When there is no power here. The only time that you use quotient rule in calculus. Otherwise, move it up, you apply the product rule. So you have only two cases, for the chain rule. So I move it up, I have to use parentheses, 8x plus 1, okay, times it by x squared plus 2 cosine of x, everything to the negative 10. You see, nice. So I have a product of two functions. This is going to be the first function. Okay, and this is going to be your second function. So easily, you know that you need the product rule. Remind yourself that, oh, I need this one. So my first thing to do is I just apply the product rule. Derivative of the first times second plus the second times first. I'll be happy with the first one because the derivative of 8x plus 1 would be 8. But when I want to do the second first is the chain rule, u to the negative 10. So I remind myself that I need the u to the negative 10. Again, you don't have to write this. Just get to know it. You bring the 10 down, negative 10, 1 down, negative 10 minus 1, negative 11 times that by u prime. You see? Now we are ready for it. Any question? Let's operate. So what's going to be f prime of x? F prime of x equal to derivative of the first, 8, times the second, x squared plus, okay, x squared plus 2 cosine of x minus 10. It's just derivative of the first times second. Now plus derivative of the second times first. The second is u to the negative 10. So we know that we bring the negative 10 down. It's going to be negative 10 x squared plus 2 cosine x, okay, to the negative 11, 1 done, times it by u prime, parentheses, u prime derivative of the inside, derivative of x squared 2x, is 2 times cosine, derivative of cosine negative sine, so it's going to be negative 2 times sine. So that's a derivative of a second one. Okay, the derivative of second. I didn't put the positive here because I bring the negative 10. Automatic is going to be minus. Okay, I do the power negative 10. I put it over here, negative 10, u to the negative 10 minus 1, which is a negative 11, times the u prime, which is a 2x minus 2 sine x. But remember, this is the derivative of a second function. Times it by the first function. Times it by the first function. 8x plus 1. And then you're done. There's no monomial left around, you see. They are not monomials, so you are done. You see, if you do this one with the quotient rule, then you have to simplify your final answer. It takes time to be able to do it. And besides, as I talk about it, the way we are going to operate in future, get used to it. The only time, I repeat it again, the only time that we are going to use that, okay, the quotient rule in calculus is just when there is no power here. That make it easier to apply. Okay, any question? So this is 4 official cases, but we move it into change it into the 2 cases only. You see the case that it's a power function. If it's going to be radical, of course, automatically we are going to, okay, rewrite it. And the case of the product really, because if you get a quotient, over here, so we move it up and we make it as a product of 2 functions. Okay, it's going to be as a product of 2 functions, so that make it easier for us to operate with these functions and with that. Any question? They give you a couple of special cases for the rational function, which is very popular. We use quite a lot. So I give you those as well. Then avoid. Okay, my suggestion is avoid the quotient rule for this type of functions. Let's check this one. So you may say this, g of x equal to, so on the top you may have 1, and on the bottom you may have something like cube root of x squared plus 5, let's say tangent of x. You see this one? You have a combination of the radical and the rational function. So what we have to do, we have to get rid of this radical. You know, that would be x squared plus 5x raised to the 1/3. And at the same time, we move it up. Okay, so that make it easy for you to be able to handle this function. It's very popular. So the solution is going to be, I'm going to rewrite it carefully. So that give you x squared plus 5 tangent of x, everything to the negative 1/3. Negative 1/3 because the radical is on the denominator. So now it's easy to operate because this is simply u to the negative 1/3 prime. And you know that would be what? Bring the power down. Negative 1/3 u to the negative 1/3 minus 1, negative 2/3 times u prime. Okay, it's not bad for yourself to practice the formula first. And of course, you don't have to write it. So that's going to be your g prime. Copy the formula. So it's going to be negative 1/3 x squared plus 5 tan x to the negative 1/3 minus 1, negative 2/3.
Is it not negative 4/3 as the exponent?
No. It's a negative 1/3. Oh, yes. You are right. Thank you. Very good. Excellent. Yes, you are right. That's a negative 1 minus 3, negative 4/3. Very good. Okay, so that's going to be negative 1/3, and this must be we bring the power down. Okay, so it's going to be negative 1/4 times it by u prime, derivative of the inside, which is going to be the 2x plus 5 times tangent, derivative of a tangent, secant square. There is no monomial left over, so that gives you the final answer. Okay, so this is very, very popular frequency. You may see it. Don't try quotient rule. Move it up. Move it up and just apply this method. There is one more. I give you a break. We come back. We do that one too. So basically, it's a four cases, but it's change it to the 2 cases only. U function and the product function. And you will see this one quite a lot in this, in this course. Okay, so it's a 9:15 almost. So let's have a break. We come back and we give you the tangent line problem that will be repeated. And we take we have to take it for the trigonometric function. So I just give you a preliminary of that one too. I may not finish it, just give you a little bit more time today in case you want to take your test today, okay? And give you more time to, to understand the chain rule. This is going to be very important for us. Okay, so let's have a break. We come back and then we finish it. See you then. Okay, we're going to continue, give you a couple of more examples that we have. Any questions so far? So I was just focusing on those quotient one, that the way we are going to do it in future, which is easier. So the last example of this group is a kind of a general types that you may be given. Okay, so just going to the next page to explain it. And these are only possibilities really that we are going to have. So what is going to be this last one? So, you know, just put something. So that would be number 8. Okay, in number 8, suppose you have this function, g of x equal to, okay, it's going to be g of x. And the top we get the x squared. And on the bottom, we are going to have a x cubed. Okay, x cubed, suppose x cubed plus 2 secant of x. Okay, it's kind of the most general case that you may be given. Again, you say some people, they just, we have to rewrite the radical. That's first step. When you rewrite the radical, it's going to be a quotient of 2 functions. Again, some people, they go with the quotient, but my suggestion is move it up. It would be so useful in the second part of the course. I told you, notion of integration, and we want to get the habit of changing this, okay, rewriting it. So this is it. So it's important to rewrite it. So that gives us a g of x. Okay, we move this one up. It's going to be x cubed plus 2 secant x to the 1/2. But since you move it up, it will be negative 1/2. So we're going to have x squared times x cubed plus 2 secant of x, everything to the negative 1/2. That's the best way to do this problem. Okay, now it would be just a previous case. It's a product of 2 functions. Okay, this is going to be your first function. And this is going to be your second function. So we apply the product rule first. But I just remind you again that I have to use the product rule first. So it's going to be derivative of the first plus derivative of the second times first. And in the meantime, I need u to the negative 1/2 for the second one. So it's going to be u to the negative 1/2 prime. And this is going to be negative 1/2 u to the negative 1/2 minus 1. That give me negative 3/2 times the u prime. Okay, be prepared. Remind yourself of the formulas that we're going to apply. So there you are. G prime of x is going to be derivative of the first times second. If of x squared, we do 2x times the second function, x cubed plus 2 secant of x to the what? To the negative 3/2. Sorry, this is derivative of the first times second as is. That's the first part. Okay, derivative of the first one, 2x times the second function. Now the second times first, we have to apply the chain rule here. So u to the negative 1/2, copy that formula, negative 1/2. Okay, x cubed plus 2 secant of x to the negative 3/2. Okay, but times it by u prime. U prime derivative of the inside would be 3x squared plus 2 secant of x, 2 times derivative of a secant, which is a secant x tangent x. Okay, that would be the derivative of a second one. So bring the negative 1/2 down. So that gives u to the negative 3/2. Okay, u to the negative 3/2 times u prime, 3x squared plus 2 times secant, 2 times derivative of a secant 10, but multiply by the first one. But some people, they miss this one. Multiply by the first, which is x squared. Okay, take care of the monomial. Just see we have the x squared left over here and the 1/2. So what I do, I had to move it here. So it would be nice, but mathematically it's correct even if you write this one because there is nothing to be simplified. So g prime of x is going to be equal to the repeated 2x times x cubed plus 2 secant of x to the negative half. Repeat everything, but it's going to be negative 1/2 x squared. Okay, negative 1/2 x squared times x cubed plus 2 secant of x to the negative 3/2 times the 3x squared plus 2 secant of x tangent of x, and then you're done. Okay, this is the kind of most general problem that you can have in this section. Okay, nothing else. Any question? So avoid the question really for this one because it takes so much time to do it. I've seen some people, they do it, they like it. They do it, they do the algebra, but this is the calculus part. Okay, this is the one we need. So make it easier for yourself and for the future applications, of course, that we're going to have. Okay, so that's it. That's a first group of the differentiation of the chain rule type question. Quickly, application, of course. Application is a tangent line problem, remember? A function would be given and you've been asked to find the equation of a tangent line to the graph of that function, okay? And we give you one on the next quiz and the test. So always tangent line problem, okay? That's it. Example. So this is going to be the example of the tangent line problem. It's a kind of a unique problem. They usually go with the radical function. Okay, so there you are. So find, we'd like you to find the equation. Find the equation. Okay, the equation of a tangent line. Equation of a tangent line to the graph. Okay, equation tangent line to the graph of this function. It's going to be radical form, f of x, radical function. F of x equal to the cube root. Okay, cube root of 1 plus 7x. Where at the point with, or at the point, with x value 1. That's it. So it's like the one that you did before, but your function is different. You know that you have 2 steps. Step 1, of course, we need a point. So the x coordinate is given, x equal to 1. So as usual, we plug in into the equation of the function. So that gives you the y coordinate. Then we have to find the slope. But the slope is derivative of the function. This is where the chain rule is coming. Because you have to rewrite it. If you rewrite it, that gives you a parenthesis 1 plus 7x to the 1/3. And for that case, you have to use the chain rule. Okay, so this is where the chain rule is coming. So that's it. Solution. Step 1, I need a point. Okay, so we need a point. X is equal to 1. So we find f of 1. So f of 1 would be cube root. Replace the x by 1, that gives 1 plus 7. Okay, 1 plus 7 would be 8, so that gives you a cube root of 8. And the cube root of 8 is equal to 2. So we have a point. You may call it a point P. So we have a 1 and 2. This is going to be step 1. Okay, step 2. Step 2 is just the slope, m. This is calculus. The slope is derivative of function at 1. So we have to find the derivative. But to find the derivative, we have to rewrite the function. Okay, so we rewrite the function f of x equal to is 1 plus 7x, okay, to a third. So we are going to differentiate it. We remind ourselves that, oh, it's like a u function. So remind yourself that you have a u to the third, and you want to find the derivative of u to the 1/3. So you bring the 1/3 down, it's going to be 1/3 u to the 1/3 minus 1, which is going to be negative 2/3 times u prime. Okay. So go ahead and differentiate it. So that gives f prime of x equal to, bring the power down, 1/3, 1 plus 7x, the power 1 down, negative 2/3 times the u prime. U prime derivative of the inside, derivative of 1 plus 7x would be just 7. So we have the monomial, put them together. So f prime of x is going to be 7/3 times 1 plus 7x to the negative 1/3. This is going to be your f prime. Any question? But remember, you need f prime of 1. So find f prime of 1. So what's going to be f prime of 1? Replace the x by 1, that gives you 7/3. Okay, replace x by 1, so that gives you 1 plus 7 to the negative 2/3. Okay, you have to simplify this. 1 plus 7 would be 8. So keep up is 7/3. That gives you 8 to the negative 2/3. You can use your calculator to find it, or this is the way we do it. So 8 to the 1/3 would be, you see, it's equal to the 7/3. 8 to the 1/3 would be cube root of 8, which is 2. 2 squared would be 4. Okay, but since it's a negative, that gives you a quarter. Okay, I just show you here. You see, this is the way you operate. It's 8 to the negative 2/3. You can do the 8 to the 1/3 first. Okay, then to the negative 2. 8 to the 1/3 is cube root of 8, which is 2. So 2 to the negative 2, 2 to the positive 2 would be 4, but it's a negative. So that give you, okay, give you 1/4, a quarter. Any question? It's always the case. There's going to be a radical function, you know. Just pick the method that you are able to get this one done. So it's going to be 7/12. And this is going to be the slope. Okay, so the slope would be 7/12. Okay, so we have a point and we have the slope. Now we can write the equation of a tangent line. Any question? So equation of a tangent line, y minus y1, remember, it's going to be y minus y1 is equal to 2, equal to the m 7/12 times x minus x1, which is a -1. And you have to simplify it. So distribute the 7/12 inside, so that gives us 7. 12x minus 7/12. And you have to add the 2 to the other side. So y is equal to 7/12x, okay, minus 7/12 plus 2. And you simplify this. So it's going to be 7/12 x. This is minus 7/12. And you can write the 2 as a 4/12. I'm sorry, 24/12. 12. So 7 out of 24 would be 17. Okay, so the final answer is going to be 712x, 712x plus 1712. 1712. So this is going to be the final answer. Y equal to, okay, y equal to the 712x plus 17 over 12. So that would give us the final answer to get these numbers done. Okay. Any question? So that would finish the first part of this application of the chain rule. So the first part, we just using that formula u to the, okay, just u to the n that we talk about it, and we considered 4 different cases and the problem of the tangent line. Yeah, okay, and this is going to be the first type. We have one more application, and that would be application to the trigonometric function. I'll do that one tomorrow because that would be too much for the chain rule, and I want to give you a little bit time if you want to, okay, prepare for your test. So we are not going to do the second part today. We leave this one and we continue because there is going to be the type that we're going to apply to the trigonometric function, and that would be 2 different cases. We do tomorrow and we finish it. Okay, so that's it for today. Just prepare for the test if you want to take the test or if you want to prepare. But tomorrow I finish this one and we continue. We continue with this 2.4 and the 2.5. It's again a kind of chain rule type. We can do it tomorrow. Okay, any question? So that's it for today. Just give you 40 minutes, 30 minutes off to prepare, and then we continue this one tomorrow. Any question? So if you haven't done it, you have to have an appointment, remember, to be able to get through the ABC. Okay, have a good one and good luck with your test. Be careful, write whatever you know. Write precisely so that you're not going to miss any point. Any question, just let me know. Have a good one and see you tomorrow. Bye-bye.